All right, hello geometry. Happy Thursday. Today is February 16th, 2 days after Valentine's Day. Um, so the plan for today is to um do a little bit of review. We'll look over Schoology, we'll talk about character strong, we'll review really kind of the quadrilaterals unit as a whole, specifically about squares, because that was kind of the new piece of information. And after that, we will get some time to practice some problems. And I'll show you sort of not necessarily a cheat sheet, but something that we can use to sort of help us. And then we'll do some problems and we will be on our way. So let us dig into it. Let's first start with Schoology. All right. All right. So if we look at Schoology, we are in week 3. So again, it is, if we're struggling, if we're falling behind, if we've got missing work, please reach out. Okay. We've got plenty of time to get caught up, but the more that we wait and the more that we procrastinate, the harder it's going to be to get caught up. So if we look at our pacing guide, and again, we scroll down week 1, week 2, week 3. Next week, okay, so we've got our work for this week. Next week, there's no school on Monday or Tuesday. So we definitely have a lighter class load next week. You guys get a 5-day weekend. Mr. Larson has to go to school on Tuesday, okay? This is a teacher work day. But you guys get, so you get Saturday, Sunday, Monday, Tuesday, 4-day weekend, excuse me. And then there's one more lesson that we've got to do, and then we're going to review, and then you'll take your test. So that's kind of looking ahead. Again, we're almost done with Unit 8. Okay, we've been working on it for quite a while. We are almost done with our quadrilaterals unit. So what did we talk about this week? We talked about different quadrilaterals. And so we talked about how a quadrilateral is any, let's make this a little bit bigger, is any four-sided figure. A parallelogram has 2 pairs of parallel sides. A trapezoid, and again, I think we'll learn more about trapezoids and kites next week. Exactly 1 pair of parallel sides. Rectangles have right angles. Rhombuses have 4 equal sides. And the joke that Mr. Larson makes that if a rectangle and a rhombus had a baby, they would have a square, which is a combination of the two. You've got 4 right angles and you've got 4 equal sides. Sorry, I had to let someone in. Welcome. We're doing some review. Okay, so again, examples, quadrilaterals here, not a closed figure, automatically not a quadrilateral, doesn't have 4 sides, not a quadrilateral. Okay, so again, what are the 2 are quadrilaterals? That would be A and C. B and D would not be. All right, identifying parallelograms. I want to get down to rectangles and squares. Okay, rhombus, perfect. What is a square? The square is a quadrilateral with 4 equal sides and 4 right angles. Which 2 of the following shapes are squares? Again, we would like to see more examples, like we'd like to see right angles here. We'd like to see congruence marks, but it's going to be A and C. All right, so which of these quadrilaterals are parallelograms? I want you to look between these 3. 1, 2, 3. I want you to determine parallelogram, not a parallelogram. I'm going to go ahead and say that The first one is a parallelogram and the other two are not. Yay. Okay. So that was a really quick review. Now let's kind of add some, well, before we jump into it, this is what I wanted to show you when I was describing. It's not necessarily a cheat sheet, but I would strongly recommend, I'm going to actually post this on our Schoology page. So again, you guys can access this again, but this is going to kind of be like your helpful, your go-to for when, what is a shape, what properties does it have? This is going to let you know. So again, which shapes have all sides congruent? Rhombuses and squares. Now, of course, if they have all sides congruent, their opposite sides are also going to be congruent. And then, sorry about that, my dog was going crazy. Opposite sides are parallel, occur in these four shapes. Right angles bisect each other. So again, we can come back to this, and I'm going to post this on Schoology. But I think if you are taking a quiz, taking a test, keeping this by you is going to help you because you can reference which properties apply to each specific shape. And then there's kind of a couple different flow charts, but stuff like this, like, does it have parallel lines? No. Okay. Are the sides congruent? No. It's a quadrilateral. Yes. Kite. So you can kind of go about these questions asking yourself, hey, does it have parallel lines? Yes. Are the angles right? No. Are all sides congruent? No. Okay. Are all angles right? Yes. All sides congruent? Yes. Maybe I'll post this one too, because I think this is also really helpful when you're going through and trying to decide what properties apply to which shapes. These can be a little bit tricky, so go ahead. I want you to take some time. And we always use, when we're doing these, the most specific name. So what is the most specific name that you could give this? Could you call this a quadrilateral? Absolutely. But is that the most specific? So 30 seconds, I want you to try to come up with 1, 2, and 3. What's the most specific name of all these shapes right here? What's the most specific that you can call it? BRB. All right, volunteers. Looks like, okay, thanks, Jay. Emma, thank you. Rectangle, I agree. Down here, trapezoid. So if we jump to our kind of our cheat sheet, trapezoids, got this toolbar stuck up here. Hold on 1 second. See if I can move it. It's right in the way. So if I look at trapezoids, oh, I got it. Okay, so because this is a right angle and this is a right angle, we know that these two lines are parallel, okay? And trapezoids have one set of parallel lines. So, and you can think about, we know that if they have two 90-degree angles, they have to be going in like a straight line forever without touching. So that's why this is a trapezoid, because if this line and this line is parallel, we have a trapezoid. And I believe you guys will learn more about that next week, so don't worry too much about that. And this one's going to be a square. Again, rectangle and a rhombus, equal sides, right angles, makes a square. All right, look at these next two again. This one, I believe you'll learn next week. This is an example of a kite because they have two consecutive sides that are congruent. So these two sides are the same and these two sides are the same. If we think about what we just talked about, it's got to have two sets of parallel lines. Well, that's going to be a trapezoid. And then this is congruent to this. This is congruent to this. That's going to be a kite. This sort of symbolism here means this line is parallel to this line and this line is congruent to this line. So what's true if we have one set of parallel and congruent lines? If I look, one set of parallel and congruent lines, I believe that's going to be a parallelogram. All right, let's keep going. Every square is a rhombus. True or false? Let's have everyone go ahead, give us your best. Type T in the chat for true, F in the chat for false. Every square is a rhombus. That is going to be true. However, is every rhombus a square? Is every rhombus a square? What do we think about that one? False, exactly. So they kind of work. Again, one is more specific than another. A square is much more specific. There has to be more properties than a rhombus. We'll skip trapezoid for now. We'll skip kite. Not sure why the answer is shown, but every rectangle is a square. No, that's not true. Every parallelogram is a quadrilateral. Yes, absolutely. And if a figure has congruent diagonals, it must be a rectangle. So let's double check. If a figure has congruent diagonals, it must be a rectangle. If I go to my notes, if I look at my little cheat sheet, congruent diagonals, rectangle is true, but I could also have a square and I could also have an isosceles trapezoid. So as we think about these, if you can come up with one counterexample, if you can find one way that it's not true, then it must be false. Okay. Last little bit. Okay, we're 13 minutes in. Pretty good. All right. So these are kind of, again, combining algebra with our properties. I'm going to give you some time to go over these. Again, try number 34 first, and then if you have more time, you can try some of these other ones. So I'm going to give you, let's say about 6 minutes to try. Start with 34 because that's the one we're going to do together because square is kind of our big theme for this week. And then if you have more time, you've learned about rhombuses, you've learned about rectangles, and you've learned about parallelograms, so you can try those as well. So go ahead, take some time, 6 minutes, 5.5 minutes now. Try this on your own. If you're stuck, I'm going to give you a hint on number 34 in about 30 seconds. All right. So your hint, if you already got it, keep working. But your hint, if you're stuck, is to, hey, let's look at what do we know? So we know that A to M is 3x plus 5. We know that B to or D to M is 5x minus 19. And if we look at our notes, we know that, whoa, there it goes. We know that this segment right here is exactly the same as this segment. They're congruent. And so when we know that two sides are congruent, we can set them equal to each other. So to find out what X is in this problem, we need to solve this after setting them equal to each other. The second part of the problem says, hey, what's this? What's this angle right here? Again, let's check our properties of a square. The properties of a square say that the diagonals are perpendicular. They meet at 90 degrees. So I need to take whatever this angle equals and set it equal to 90 degrees to go ahead and solve for that. That's your hint for 34. I'm going to put the problems back. You got about 3 more minutes. Does anyone have questions about 34 or any of the other ones? I can give you a hint. Everything we do in geometry is about using what we know to find out what we don't know. How do we apply these properties to determine what we need to know? How do we use these properties to simplify, to whittle things down? All right, I'm going to go ahead and solve number 34. Again, if you have other questions, please email me. Please let me know. I'd be happy to go through these with you, especially before you take your quiz or your test. Okay. Got to know how to solve these. So, this first one, again, once I get to this point, I got to separate my left and my right side, and I got to get all my x's on one side. So, to do that, I'm going to subtract 3x. To do that over here, I'm going to add 19. Yeah, Mr. Larson, I'm doing 2 steps at once. That's naughty. I shouldn't do that. 2x 19 plus 5 is 24. Divide by 2. Divide by 2. Therefore, I get x equal to 12. And for this case, let's just change this x to a y so that we're using two different variables. Again, the key, how did we figure this one out, is that perpendicular diagonals. So if we look at our cheat sheet, let me pull that up. Again, if we look at our cheat sheet, I'm going to say, oh yeah, I know that in a square, the diagonals bisect each other, diagonals are congruent, and diagonals are perpendicular. That's the piece I need, because perpendicular means meets at 90 degrees. That's a word we've been using since almost the first day of geometry. Oops. So again, two-step equation, subtract 42, 3y equals, I believe that's 48. And when we divide by 3 on both sides, we're going to get y is equal to 16. Before you take your quiz, you should hopefully have a good understanding or be able to solve most of these types of problems, okay? How do I use what I know to determine parallelograms, rectangles, rhombuses, and squares? How do I use these properties to solve? All right, so our Class Connect assignment, again, from our main Schoology page, I open up the Class Connect assignments folder. All right, we just did this one together, so hopefully you wrote it down. Hopefully you were following along. We just did this one. And we did some of these too. A rectangle is always, sometimes, or never a square. A square is always, sometimes, or never a rectangle. A rhombus is always, sometimes, or never a square. A rhombus is always, sometimes, or never a rectangle. Use your notes, check that out. I'm gonna make sure that I post, once I'm done with all my class connects this morning, it will probably be in an hour or two. I will post that cheat sheet. That's what I call it. It's not a cheat sheet. It's just notes. I'm going to post those notes of all those properties on Schoology. And again, you are more than welcome to use those however you feel is fitting. All right, that's all I have for you. Our character strong word of the month is honesty. So again, think about honesty. And here's my thought-provoking question for you. No need to answer, just think about it. Is there ever a time where it's okay to be dishonest? Is there ever a time where it's okay or acceptable to be dishonest? Think about that as you leave. Don't forget to fill out your Class Connect assignment, because that's how you get credit. Have a great rest of your day. It's a short week next week, so we will not meet next week. All right. Goodbye, geometry. Have a great weekend. Bye, Jay.